Good evening all. Now we will solve some problems on resonance. Okay, what is the total reactance of a series RLC circuit? Okay, at resonance. Okay, under resonance condition net reactance value is 0, right? See here total impedance Z is equals to R plus impedance Z is equals to R plus J XL minus XC. Under resonance condition XL minus XC value is 0, XL is equals to XC. That means this value is 0, right? That means total impedance value is equals to resistance only. That means first answer is correct, equal to R. Okay, what is the phase angle of a series RLC circuit at resonance? Under resonance condition total impedance is equals to resistor only, right? Then in case of resistor, voltage and current both are in phase, then the phase angle will be 0. Okay, that is second one. Next, in a series RLC circuit, L is equals to 15 millihenry, C is equals to 0.015 microfarad and R is equals to 80 ohm. Okay, what is the impedance at the resonant frequency? Okay, under resonance condition XL is equals to XC, right? These two values are cancel each other. Then total impedance will be only resistor, that is equals to 80 ohms only. Okay, next problem. In a series RLC circuit operating below the resonant frequency, the current, okay, in a series RLC circuit the operating below the resonant frequency, right? If we draw the graph between resonant frequency versus impedance, okay, this is the graph. Okay, this is Z, impedance is minimum under resonance frequency, this is Z minimum. Here omega naught is the resonance frequency, this is the less than resonance frequency, this is more than above resonance frequency. Now see here, above the resonance frequency the nature of circuit is RC circuit, sorry, below the resonance frequency the nature of circuit is RC. Okay, above the resonance frequency RL. Why? Because Z is equals to R plus J into XL minus XC, right? Impedance value, that is R plus J into XL value is nothing but omega L minus 1 by omega C, right? When frequency is 0, this value is dominating, right? That means the nature will be capacitive. After that inductance value is dominating. That means here current leads voltage is the correct, right? In case of RC circuit, current leads voltage. Above the resonance frequency means RL circuit, that is current lags voltage. That means second option is correct in case of above the resonance frequency. But here what is asking, in a series RLC circuit operating below the resonant frequency, right? Below the resonance frequency, that is current leads voltage. Next, in a series RLC circuit, if C value is increased, what happens to the resonance frequency? Okay, what is the formula for resonant frequency? Resonant frequency FR is equals to 1 by 2 pi under root LC, right? When capacitance value is increases, what is the effect on resonant frequency? Inverse proportion, right? Resonant frequency is reduces, that means it decreases the resonant frequency. That means second option is correct. Next, in a certain series resonant circuit, voltage across capacitor is equals to 150 volts, voltage across the inductor is equals to 150 volts and voltage across resistor is 50 volts. What is the value of the source voltage? Okay, here is given under resonance, right? Under resonance condition VL is equals to VC, but these two are in opposite sign, then the resultant value will be 0. VL minus VC is 0, right? What is the formula in case of RC circuit? Total voltage V is equals to VR square plus VL minus VC whole square, right? VL is 150 is given, VC is 150, this value is 0, then total voltage is equals to voltage across resistor only, right? Under resonance condition total supply voltage is equals to voltage across resistor only, that is 50 volts is the answer, that is on option B. Next, in a certain series resonant circuit has a bandwidth of 1000 Hz. Okay, if the existing coil is replaced by a coil with lower quality factor, okay, Q factor is inversely proportional to bandwidth. Okay, when quality factor is low, bandwidth is increases, right? When quality factor is low, bandwidth is increases. That means see here, first option it increases. That means first option is correct. Right, quality factor is reduced, low value, then bandwidth is increases. Next, in a parallel resonance circuit, why does the current lags behind the voltage at frequency below the resonance frequency? Okay, why? Because in parallel, series means first starting RC nature, below the resonance frequency, above the resonance frequency RL. That is in case of series. In case of parallel, below the resonance frequency, the nature of circuit is RL. Okay, because the circuit is predominantly inductive. Okay, that means second option is correct. Next, in order to tune a parallel resonance circuit to a lower frequency, the capacitance must be increases. Okay, next, what is the impedance of an ideal parallel resonant circuit without resistance in either branch? Okay, parallel means it is infinite. If it is series resonance, its value is 0. Where is infinite? First option is wrong, second option is also wrong, third option is also wrong, fourth one is infinite, right? This one is correct. Next, if the lower cutoff frequency is 2400 Hz and upper cutoff frequency is 2800 Hz, what is the bandwidth? Bandwidth is nothing but higher cutoff frequency minus lower cutoff frequency. That is 2800 minus 2400, you will get 400 Hz is the answer. Okay. Mutual inductance is a property associated with. Okay, mutual inductance, for mutual inductance it should have two coils, right? And two coils should be magnetically coupled. See here, first option only one coil, that is not correct. Two or more coils, that is correct, but there is no magnetic coupling, right? Third option, see here, two or more coils with magnetical coupling, that means third answer is correct. Next, dot convention in coupled circuits is used. First one, to measure the mutual inductance, not correct. To determine the polarities of the mutual induced voltages in the coil, that is second option is correct. We need to identify the polarities of mutual induced coils only. Option B is correct. Next, mutually induced voltage is present independently of, and in addition to the voltage due to self-induction, right? Self-induction, that means self-induced voltage is present as well as mutual. Because of self only mutual is present, right? That means that statement is true. Okay. Next, two terminals belongs to two terminals belonging to different coils are marked identically with dots. If the different direction of current relative to like terminals, the magnetic flux of self and mutual induction in each circuit add together. Okay, see here, two coils, right? Current, both the coils current is entering, or this is current entering, dot indicates current entering into the coil. Okay, both in this case also current is added, right? In this case flux is added. If two coils current is leaving, dot represents current leaving or entering into the coil. Here current is leaving, in both the cases current is leaving the coil, right? Here also mutual induced or mutual fluxes will be added. That means this statement is also true. Next, the maximum value of the coefficient of coupling is, that is 100%, right? Coefficient of coupling, okay, k value is varies between 0 to 1. Okay, that is m is equals to k into under root L1 into L2. M is mutual inductance, k is coefficient of coupling, L1 L2 are the self inductances of a coil. Okay, k value is varies between 0 to 1. 0 means 0%, 1 means 100%. Okay, maximum value is 100%. Next, the case for which the coefficient of coupling k is equals to 1 is called as perfect coupling, right? Here k value is 1 is maximum, that means that is a perfect coupling. That is also true. Next, the maximum possible mutual inductance of two inductively coupled coils with self inductances L1 is equals to 25 millihenry and L2 is equals to 100 millihenry is given by, okay, what is given? L1 value is given, L2 value is given, right? What is the maximum possible mutual inductance? That means he is asking mutual inductance maximum possible. Maximum means here maximum L1 L2 values is given, right? When K value is equals to 1, then only we will get maximum mutual inductance, right? That is M is equals to K value 1 into under root L1 into L2. Here L1 L2 values are given, right? That is 25 millihenry and 100 millihenry, right? That is 25 into 100, that is 2500, that is 50 square, right? Yes, 50 millihenry is the correct answer. Next, the value of the coefficient of coupling is more for air core coupled circuits compared to the iron core coupled circuits. No, that is second option false. Next, two inductors are connected as shown in figure. What is the value of effective inductance of the combination? Option A 8, option B 10, option C 4. Now see the circuit diagram. Okay, this is the circuit diagram he is given. Now see here, this is coil 1, this is coil 2, right? In coil 1 also current is entering. This is entering point, this is leaving point. This is entering point, this is leaving point, right? Coil 1 current is entering, coil 2 dot indicates current leaving, right? That means see here, let us consider coil, two coils are connected in series. Okay, in two coils if current is entering, mutual induced EMF M is positive. If two coils current is leaving, right, in two coils also current is leaving, also mutual induced EMF is positive. Okay, if one coil current is entering, in one coil current is leaving, okay, then mutual inductance is negative minus M. Now see here, from this given question, in this coil current is entering, right? In this coil current is leaving, right? First one is L1 equivalent is equals to self inductance value is 3 Henry is given. Okay, mutual inductance, the inductance between coil 1 and coil 2 is, this is mutual inductance is 2 Henry is given, right? This is minus 2 Henry. What is the value L1 equivalent? 1 Henry. Similarly, L2 equivalent is equals to self inductance value is 5 Henry. Mutual inductance is minus. Why? Because here leaving, here entering. That is minus 2 Henry. You will get 3 Henry. Then total L equivalent is equals to L1 equivalent plus L2 equivalent. That value will be 1 plus 3. You will get 4 Henry is the answer. Okay. That means this question answer is 4 Henry. Next. Two coils are connected in series, have an equivalent inductance of 3 Henry when connected in aiding. If the self inductance of the first coil is 1 Henry, what is the self inductance of the second coil? Assume M is equals to 0.5 Henry. Okay, what is given? L equivalent is given, right? L equivalent is 3 Henry. Okay, see here L equivalent is given as 3 Henry, right? When connected in aiding, okay, the L equivalent formula will be L equivalent is equals to L1 plus L2 plus or minus 2M plus for aiding minus for subtracting or opposing. Aiding and opposing. Now see here in this problem what is given? Two coils connected in series having a equivalent inductance of 3 Henry when connected in aiding, right? Then formula will be L equivalent is equals to L1 plus L2 plus 2M. L equivalent value is 3 Henry is given, right? If the self inductance of the first coil is 1 Henry, that means L1 is given. What is the self inductance of the second coil? Assume M is equals to 0.5. That means L1 value is 1 Henry is given, plus L2 we need to calculate, plus 2 into mutual inductance value is assume 0.5, right? 1 plus 2 into 0.5, 1, that is L2 is equals to 3 Henry minus 2, you will get 1 Henry as answer. L2 is equals to 1 Henry. Okay, that is first answer. Next, last problem. Okay, for the circuit shown below, the inductance matrix. Now see here 2 Henry is the self inductance, 1 Henry is also self inductance, 3 Henry is also self inductance of this is first inductance, second inductance, third inductance. Okay, this is 3 Henry is the mutual inductance between 1 and 2, right? Next, 1 and 3, 1 Henry, 2 and 3, 2 Henry. That means total possible matrix is 3 by 3, right? L11, L12, L13, L21, L22, L23, L31, L32, L33, right? L11 is nothing but self inductance, 2 Henry. Okay, that means L11 value is 2. Check the three options 2. Okay, all are correct. Next, L12, in between 1 and 2, 3 Henry is possible present, right? Here current is entering, here current is leaving, right? Current entering the dot, current leaving the dot. That means mutual inductance is minus, that is minus 3. This is not correct. Minus 3, okay. This is also minus 3. That means either B or C. Next, L13, current entering. Then mutual inductance will be plus 1. Plus 1, okay. Next, L21, 21, right? Again minus 3. Here plus 3. That means option B is correct. Okay. Thank you all.